Let's start. Three-dimension geometry. We are basically going to do straight lines in 3D. I hope all of you remember the concept of drs and DCs. If there is a line segment joining two points, before we start straight line, I must remind you, joining A and B, x2, y2 and z2, then the vector AB is given by position vector of B minus position vector of A. x2 minus x1 I, y2 minus y1 j, z2 minus z1 k. This is AB. So drs are drs of AB are what? A equal to this, B equal to this, and C equal to this. Okay? So using this we can write the DCs of the line. DCs accordingly. L A by root over sigma A square and n equal to, isn't it? All these you know. Now one thing we can state from here, L is to M is to N is A is to B is to C. This is okay. This we keep in our mind always. Now let us write equation of straight line in 3D. We'll write line in 3D. What is requirement? Everything will be done by vector. Scalar form is not so important here, because when you are good at using vector form, scalar form automatically arises. Equation of line in 3D. We are going to discuss one point form. What is that? Let us write the statement. To find the equation of line, to find the equation of a line passing through a point A, whose position vector A, and parallel to the vector B. This is enough. If you know a point and direction, in 2D what you have seen, if you know the slope and a point, then one point form is there. Direction ratio, direction cosine plays the role of that slope over there. Okay? So let us write the equation of a line passing through this and parallel to vector B. So this is your line. It is passing through the point A. This point is A. It is parallel to this vector B. We have to write the equation of this line. You just know equation of anything in 2D based on x and y. In 3D it will be x, y, z. 2D straight line we are not going to discuss. Okay? We are going to discuss 3D. line in 3D. So XYZ will be an arbitrary point here that we are taking as P. Let PR be an arbitrary point on the line. So AP vector will be what? Position vector of P minus position vector of A, R minus A, since parallel we can write where T is a scalar. You must agree, in vector you have seen two parallel vector, one is the scalar multiple of the other, but AP is R minus A. Therefore R equal to A plus TB. This is the equation of line. So let us write one example based on it. Equation of line, so do it in scalar form first. Equation of line in scalar form. This is in vector form. Or this has another name that is called symmetrical form. You take R equal to what? R is an arbitrary point. A known point. B you take AI, BJ, CK. This be different. They are not same. Then from 1 R minus A equal to TB, you find R minus A. T into AI, BJ, CK. So now compare. Comparing we get TA, Y minus Y1, TB, TC. Isn't it? Check. So if we compare, then we get this thing. The line is this is the equation in scalar form. Okay, line in scalar form. Vector form you understand, scalar form also you understand. So let us solve one example based on it. Question number 1. Write the equation of line passing through 2i minus j plus 3k and parallel to the vector I plus 4j minus 7k. Equation of lines, scalar and vector both. You can write answer in one line only, isn't it? How to? R equal to A plus TB. A is this. Alright, done? Yes. And this is quite obvious. This is vector form, scalar form we write. X minus x1 by A, y minus y1 by B, clear? Done? If lines are parallel, which part will be the same? For parallel lines, they have the same direction ratios. So write another question. Write the equation of line parallel to and passing through 4 2 minus 5. Just do this. Equation of line parallel to this and passing through this point. Same ABC will be there, no? So equation is, required equation is am I correct? Done? Because same direction ratio. Two-point form. Points enough. we don't need direction distribution. Okay, see how I am showing you. Vector is a great help here. Concept of vector. We are going to write equation of this line passing through A and B. Okay, these 2 points enough. So you can start the same manner. Let P be an arbitrary point on the line. PR be an arbitrary point on the line as A, B and P are collinear, so AP equal to T into AB. Isn't it? AP is what? AB is what? B minus A. So required equation is clear? In scalar form, you take A as okay, then you can show that this is going to be, or you can derive it from here, R equal to A plus T into B minus A. R is what? Is B minus A so like previous one, comparing, you can write because if you take it on left side and compare, you will be doing the same manner. So I did not show that step, you understand. So 2-point form, vector form is here and scalar form is here. Solve one problem where you have to write both scalar and vector. Write a question here. Write the scalar and vector, or as you like, of line passing through 2, 1, 4 and 3, 7, minus 1. Do this one. Get both the form. Idea should be clear. Try to write. Done?
So what?
You can start with this form. x2 minus x1 y2 minus y1 this is the scalar form 2.4 and vector form r equal to, from here we start writing a plus tb. A is what? A point on the line 2, 1, 4. Plus t into this thing. I 6j minus 5k. You agree or not?
Yes.
Clear? Now let us find angle between two lines. This is one line, this is another line. Which one?
t bracket I cap plus 6j cap minus 3k cap.
No, it's coming 5. Minus 1 minus 4, yeah. So these are two lines in 3D. You have to find angle between them. This is first line L1, second line L2. First line equation be A1 TB1. L2 be SB2. Okay? So first line directed along what? V1. Agree? Second line V2. So angle between L1 and L2 is the angle between V1 and V2. Agree?
Yes.
Dot product you have just done in vector. So required angle same thing. Sometimes it helps, that's why I've written. Cos inverse B1 cap dot B2 cap. Now you will write the expression in terms of scalar form. I'll wait for your response. This is one line. Okay. You need to find angle between, write the expression for angle between these two lines. Try. Same thing, angle between this vector and this vector, isn't it? Angle between 1 and 2 is the angle between vectors, first one directed in what direction? And A2I, isn't it? It's clear? So again the same thing, cos theta equal to dot product of these two by this is the answer for angle between two lines in scalar form. Okay? Just write one problem. Find the angle between and just do it. Practice. Do it yourselves. This is I minus 2j plus 2k, 4i plus 5j minus 3k.
5. So 5 into 4i plus.
No, this is yes. Not 5. Understood? Clear? In straight line now you need to learn skew lines and their shortest distance. It's okay. You need to practice some sums. It is better we do it next session. You practice some sums only because it's a new topic, no? So I am sharing some document with you. Do it from there. Stop this one. No continuation of SD between skew lines. That we'll do in the next session.